In this video, we're going to add and subtract rational expressions, and we're going to do it with like bases and unlike bases. So let's start out. Here's your rules. Step number one, we're going to rewrite the problems with common denominators, just like 1/2 plus 1/3. We know that we cannot add two fractions unless the bottoms are the same. So we're going to find our common denominators. Step number two, we're going to combine the numerators and keep the same denominators, same way we would do here. Multiply top and bottom by 3, common denominator 6. So 3, 6 plus 2, 6. What do you do next? You add the tops and you keep the common denominator. Then step number 3, you see, can I simplify the expression? So the first few of these are going to be pretty easy because you already have a common denominator. So if you have a common denominator, you leave the denominator alone, 4a squared, and you simply add the tops. 13a plus 5a is an 18a. Combine the like terms. Now, last step, you do have to simplify these. Since it's a monomial on top and bottom, you can cancel anything. 18 and 4 reduces to 9 and 2. There's 2 on bottom, a's. There's 1 on top. Subtract, it leaves you with a single a on bottom. There's your final answer. Number 2, common denominator is 16 already. Leave it. The top, now you got to be careful here. This minus. This stuff is in parentheses and there's a minus in front of it. So when you go to rewrite this, which is going to be pretty necessary, make sure you distribute this minus. It's a minus 7x and a minus 2. That's the number one mistake people make here. And now the combined like terms on top, 9 minus 7x is be 2x's. 12 minus 2 would be plus 10 over 16. Now this will reduce. Factor everything that's factorable in this last step. Pull a 2 out of the top. You're left with x plus 5 over 16. Now you can cancel monomials. 2 with a 16 leaves you with a 1 and an 8. So that'd be x plus 5 over 8. Now there's another trick to that, and you can do this either way. The other method of reducing this is you can look at all three terms and ask yourself, will anything divide into all three terms? And 2x, 10, and 16 are all three divisible by 2, so you could divide by 2. Divide by 2, and divide by 2, and you end up with the exact same answer. So you can do that one either way. Number 3, you already have a common denominator, y squared minus 9. So on top, you're simply combining like terms, and with a plus sign, you don't have to worry about distributing it, because a positive 2y and a positive 20, it doesn't change. So on top, combine your like terms, you have y squared plus 8y and 2y gives you a plus 10y plus 21 over y squared minus 9 was your common denominator. Let's factor to see if anything reduces. On top, you have adds, multiplies. You have y and y. Adds, multiplies would be a positive 3 and a positive 7. On bottom, you have difference of squares, which will factor into conjugates. A y times itself gives you y squared. A 3 times itself gives you a 9. Cancel any of the binomials that they share, and you're left with a y plus 7 over y minus 3. Number 4, you already have a common denominator, so simply combine your tops. This minus, if there were two terms, it would go with both, but there's only the single term, so nothing combines on top. So it leaves you with that. And on bottom, you have your common denominator of 12a minus 3. Now let's factor. On top, you have difference of squares. Difference of squares factors into conjugates. Now, there's something I don't like about this already, though. I don't like my a stuff not being first. So what we can do to begin with is let's factor out a negative 1 to flip-flop these around, because I know down here if it's going to cancel anything, my a term's first. So let's factor out the negative 1. That's going to flip this to 16a squared minus 1, okay, on top. Now, when I go ahead and factor that, you're left with a negative, and this is also difference of squares. It's going to factor into conjugates, so you have your plus and your minus. 4a times itself gives you 16a squared, and 1 times itself gives you the 1. On bottom, the only thing that you can do is factor out a 3, and you're left with a 4a minus 1. 4a minus 1's cancel with each other, and you're left with a negative on top, along with the 4a plus 1, which you can distribute if you'd like to, and only the 3 on bottom. Number 5. You do have your common denominator. On top, you have minus this, so make sure you distribute the minus. So you have n squared plus 3n minus 7, minus n minus 1 on top, and n squared plus n minus 6 on bottom. On top, combine like terms, n squared, combine the 3 minus 1 gives you a plus 2n, negative 7, negative 1 is a negative 8. Bottom stays the same. try to factor both. You're going to do adds, multiplies, and that would be a positive 4 and a negative 2. Adds, multiplies would be a positive 3 and a negative 2. N minus 2's cancel. Final answer, n plus 4 over n plus 3. Number 6. Let's see, combine like terms on top, 13k squared plus k squared would be a 14k squared. Negative 9, positive 2 would be a negative 7k over your common denominator, 6k squared minus 5k plus 1. On top, we're going to factor out a 7 and a k. You're left with a 2k and a negative 1. On bottom, we're going to have to use bottoms up, or slip and slide, excuse me. So that's going to be k squared minus 5k plus 6. Factor like normal, that'd be a k and a k. Adds, multiplies would be a negative 2 and a negative 3. We slip the 6, so let's divide each of those by 6. Reduce them, that'd be k minus 1/3 and k minus 1/2. So now let's go ahead and move those back to the front, and we can write it over here now. You have a 3k minus 1 and a 2k minus 1. Monomials, you don't have a monomial on bottom, so this is going to stay put. The 2k minus 1s will cancel. Final answer here is going to be a 7k over 3k minus 1. Okay, on number 7, we start adding and subtracting these with unlike bases, these rational expressions. So what you've got to do here is you've got to somehow make the bases the same. The same way as if you had 1/2 plus 1/3. You multiply by something to change the bottoms to where they're identical. Here with 2x and 3x, the x's are the same. I just need to change the 2 and 3 to where they're the same. So what I'm going to do, I'm going to multiply top and bottom here by 3. We'll multiply top and bottom here by 2. And that's going to change both my bottoms to a 6x. So on the first fraction, I have a 45 over 6x now. Second fraction, I have a 32 over 6x. Now it's easy. Subtract. 45 minus 32 is a 13 over 6x. That will not factor and it will not simplify. Number 8, I have an a squared and an 8a. Well, since I have an 8 here, I need an 8 over here, so let's multiply top and bottom by 8. Here I have an a squared, here I have just an a, so let's multiply top and bottom by another a, and that's going to give me an a squared on bottom. So now I have my common denominator, which is 8a squared. On top I have 32a minus 7a, and I can now combine those. That would be 25a over 8a squared. Always check and see if you can simplify. 25 and 8 will not. However, since this is a monomial, I can cancel my a squared with my a. Leave the 25 on top. You have 2 a's on bottom, 1 on top. Subtract, and you're left with a single a on bottom. Number 9. Now we start dealing with binomials, and we need to factor these before we find common denominators. So the top will not factor. I'm going to leave it as k squared plus 16 over, factor out the 5, you're left with a k minus 2, minus, I'm going to leave a little bit of space here, 4 over the k minus 2, and I'm going to put those in parentheses. Since you have the only difference between these two bottoms is the 5. So if I multiply top and bottom here by that 5, the bottoms are now the same. This will be a 20. So on top I have k squared plus 16 minus 20 over that 5 parentheses k minus 2. Okay, on top, combine your like terms. You're left with k squared minus 4. On bottom again, you have 5 parentheses k minus 2. Always factor everything to see if anything cancels. Top, you have difference of squares. Difference of squares will always factor into conjugates. You have a k times itself gives you k squared. 2 times itself gives you the 4. On bottom again, you have the 5 and the k minus 2. So now we have a binomial here that cancels with a binomial. Final answer is going to be k plus 2 over 5. Number 10. Factor everything to begin with just to see what our common denominators look like. And again, if it will not factor, I like putting it in parentheses. Over here, you'll have a 35 over two sets of parentheses. Y times itself gives you y squared. Adds, multiplies will be a plus 3 and a plus 8. Now look at the bottoms. You have a y plus 8 over here and a y plus 3 and a y plus 8 over here. So the only difference is I need a y plus 3. Then the bottoms will be the same. So let's multiply top and bottom, and it has to be multiplication. Multiply top and bottom by y plus 3. Now the bottoms are the same. They are y plus 3 times y plus 8. Order does not matter because multiplication is commutative. On top, you have 7y plus 21 plus 35. That's going to be a 7y plus 56 over y plus 3, y plus 8. Let's factor the 7 out of the top. You're left with a y plus 8. And again, on bottom, it was y plus 3 and y plus 8. So now you do have some things that will cancel. Y plus 8s are gone, leaves you with 7 over y plus 3. Number 11. Again, always factor before you find common denominators. The top will not factor. You have x squared minus 5 over, on bottom you have an x plus 2 and an x plus 3 once you factor that, plus 1 over, I'm putting that x plus 2 in parentheses. You have an x plus 2 on both. You need an x plus 3 over here. Now the bottoms are the same. Make sure if you multiply the bottom by anything, you do it to both, top and bottom. So your common denominator is now x plus 2 times x plus 3. On top, you have x squared minus 5 plus x plus 3. Combine any like terms. On top, you now have x squared. Put your x next, and then negative 5 and positive 3 is a negative 2 over the x plus 2 times x plus 3. Factor to see if it will reduce. The top factors into what adds to give you 1, multiplies to give you negative 2, will be a positive 2 and a negative 1. On bottom, you have x plus 2 and an x plus 3. So therefore, the x plus 2's cancel. Final answer, x minus 1 over x plus 3. Number 12. Let's factor out everything that will factor. On top, you have an m plus 2 times an m plus 3. On bottom, you have difference of squares, so that'd be m plus 2, factors into conjugates, and m minus 2, plus 2 over an m minus 2. Now, you could, if you don't notice this, you could multiply top and bottom here by the m plus 2's, and it would be the same. However, that's going to create more work than it's worth. Look, you can actually just cancel those out, and you have your common denominator. So you have the common denominator of an m minus 2, and that's going to make things so much faster. And on top, you have m plus 3 plus 2, which is simply m plus 5 over the m minus 2. Final answer. Number 13. You have a w plus 1 and a w minus 7. Now, you've got to be careful because you have to multiply by things to find common denominators. So let me create myself some space here. You have a w minus 7 over here, a w plus 1 over here, so you need a w minus 7 over here. So let's multiply top and bottom by w minus 7. You need a w plus 1 over here, so multiply top and bottom by that. And now your bottoms are the same. On top, you have 5w minus 35. The positive 8 is what you're distributing, so a plus 8w plus 8. On bottom, you have a w plus 1 and a w minus 7. Add the tops by combining like terms, gives you 13w minus 27 over w plus 1 and w minus 7. The top will not factor, so therefore that's going to be your final answer. Okay, the next one, number 14. Now again, here's where it's so tempting. The number one thing that I see people doing here is try to add 3 to the top and bottom. You cannot do that. The rule is you can only multiply top and bottom by things to find that common denominator. So what we're going to have to do, your b plus 3 is in parentheses. Minus 4 over the b is in parentheses by itself, okay? You can't do anything with that. So here's what we're going to do. Multiply top and bottom by b, multiply top and bottom by b plus 3. It's so deceiving when there's only a single term, when a monomial is on bottom by itself, and you have a problem that has a monomial here and a binomial over here. That kind of confuses people. So that's it. So multiply top and bottom by b, multiply top and bottom by b plus 3. Now my bottoms are the same. You have a b and a b plus 3. On top, you have b times b, which was b squared. Now here's another part where people miss. When you distribute the 4, make sure you distribute the minus with it, because anytime you have a minus between here, that has to be distributed. Negative 4 times b is negative 4b. Negative 4 times 3 is a negative 12. Now let's try to factor the top, two sets of parentheses, a b and a b. Adds, multiplies would be a negative 6 and a positive 2. On bottom, you have a b and a b plus 3. Nothing cancels out, so therefore that's as far as we can go with it. Okay, got a couple more. Number 15. Factor the bottoms first. So you have 2 over, factor out of 4. You're left with a p minus 5 plus p minus 6 on top does not factor. Two sets of parentheses on bottom. And you have a p and a p. Adds, multiplies would be a negative 3 and a negative 5. So both bottoms have a p minus 5, so you're okay there. However, you do need a p minus 3 over here, so let's multiply top and bottom by that p minus 3. Okay, now the only thing that you're missing is the 4. You have a 4 over here, but not over here, so let's multiply top and bottom by 4. Now, if you're going to multiply the top by 4, make sure you multiply the whole top by 4. Now you have your common denominator, which is a 4, a p minus 3, and a p minus 5. On top, you have 2 times p minus 3, which go ahead and distribute. On top here, you have a positive 4 times p minus 6, which is a positive 4p minus 24. Let's combine all of our like terms. Gives me a 6p minus 30 over 4 times p minus 3 times p minus 5. The top can be factored. Pull out a 6. You're left with a p minus 5. On bottom again, you have p 4 times p minus 3 times p minus 5. Our monomials, the 6 and the 4, can reduce to a 3 and a 2. The p minus 5s reduce completely, and you're left with just the 3 on top and a 2 and a p minus 3 on bottom. And the last one, number 16. On top, you have an r. Let's factor the bottom. Pull out a 2. You're left with an r plus 4. Minus an 8, and let's pull out an r, and you're left with an r plus 4. So you're missing a 2 over here, so let's multiply, and let me do a different color. So let's multiply top and bottom by 2. And the only thing that you're missing over here would be an r, so let's multiply top and bottom by r, and you can just do r times r is r squared there. So the bottom, and it doesn't matter the order, but we like to put the number and the single variables and then the binomials last. It just looks better. And on top you have r squared minus 2 times 8, which is 16. That is difference of squares. Difference of squares factors into conjugates. You have an r and an r, plus and a minus. 4 times itself gives you 16. On bottom you have a 2r and an r plus 4. The r plus 4s will cancel. Leaves you with an r minus 4 on top and just the 2r on bottom.